once again, see here, in the Hertz experiment, actually he took a discharge tube here. Okay, he took a discharge tube like this. Okay, and like he kept one emitter plate and collector plate. So when light of certain frequency was emitted, then what happened? Electrons started ejected. Okay, so then when it was exposed to light, after some time electrons started ejected. So this particular phenomena is known as Hertz observation. The same thing what Leonard and Harvard also did the same thing. Here also when they incident that the ultraviolet radiation, UV radiation here. When they incident that UV radiation on the plate, and this is vacuum evacuated, there is no air, nothing. Why they haven't taken any air or any gas? Any reason behind it? Why they haven't taken any gas or any other air or something air like that? I mean, what is the reason behind it? Can anyone say that? Yes. Yes, anyone? Why they haven't taken any air in it?
Because it wasn't the fan and the fan was closed.
Yes, Dhruti. I think this was completed right in your class.
Fan was air.
Are you able to hear me? Yes. No one is replying.
No.
Okay. See, what happens is why we haven't taken when the electron comes out. So if there is some other gas, there the gas gets ionized. That's the reason. You know what is ionization? Removal of the electron from the outermost orbitals of a neutral gaseous atom. That is said to be ionization. So there is a phenomenon that ionization can take place inside. So for that reason, what happens? The fast moving electron. So this, when the light is incident on the plate, electrons are ejected outside. These electrons, they remove these electrons. Remove the electrons from the neutral gaseous atom. So for that reason, we never take any gas. So that is what is known as a vacuum evacuated chamber. But the best example is the tube light. What is there inside in the tube light? Have you seen the tube light roll? Have you seen the tube light roll, anyone? Like in that tube light roll, there is some gas. There is a hydrogen gas or mercury gas. Why? Because the ionization is taking place and electrons are see what happens. I will tell you. See these fast moving electrons. Suppose this is the nucleus. So what happens when the light incidents onto this one? These electrons are ejected outside. Okay. So then these electrons will come down. So when they are coming down, then what will happen? This will go to the negative plate. Sorry, positive plate. This electron will go to the positive plate. Whereas when the other electron will jump and come to that seat. Okay. When the electron jumps from higher level to lower level, it releases energy in the form of light. Understood now? It releases in the form of light. Is it clear? Yeah, inert gas. Not inert gas. I think mercury vapor gas is not inert gas. So what will happen when once again, when the electron is when the fast moving electron it hits here, then electrons are ejected out. So what happens if the atom will become unstable? So this atom will come and sit in this place, and some energy is released. Whenever an electron is jumping from higher energy level to lower energy level, energy is released. That energy we are getting from the tube light. Understood? The tube light or the bulb. This thing is happening. Even in the bulb also same thing. There is some hydrogen gas or something inside. So this because of that, what happened? Electrons are coming. That energy comes out. Is that clear? Is it clear, all of you? So here, instead of saying that emitter, he said C and A for anode. C for cathode, A for anode. Here also he says C for cathode and A for anode. Is it clear? C for cathode and A for anode. Is that clear, all of you? Now here. No. Okay. So what happened here? They studied how the photocurrent varies. So they connected it to some, they connected this one to some, a circuit and then an ammeter also. So milliammeter or microammeter. Then what happened is they saw the movement of electrons. Okay. They saw the movement of the electrons. So this happened in Leonard's observation. Is it clear, all of you? And the material here is known as photosensitive material, and the electron is known as photoelectron, and this effect is known as photoelectric effect. Is that clear? Once again, there are three things here. One is photosensitive material. Photosensitive material. The electron which is coming out is known as photoelectron. The next one is what? Photoelectric effect. Okay, photoelectric effect. Once again, see, photosensitive material, the material which is used for this purpose is photosensitive material. Okay, photosensitive material, like what are the examples of photosensitive material? Lithium, sodium, potassium, rubidium, cesium, francium, first group elements. Okay, lithium, sodium, potassium, rubidium, cesium, and francium, Fr. So these are first group elements, post 1A group elements. So they are like, they have one electron in the outermost orbitals. So it is easy to remove that electron. So that electron, whatever the electron which is coming out of the electron which is coming out of the coming out here is known as the photoelectron, and this effect is known as photoelectric effect. And there are two more things to be discussed here. One is work function, and the second is threshold work function. Work function is the minimum energy. Work function is denoted by phi. Here, what happens? This we say phi. The minimum the amount of work, or the amount of work, or the minimum energy, the minimum energy required, the minimum energy required to remove, or required to bring an electron to the surface of the metal, to the surface of the metal, is known as work function. The next one is what? How much energy? See, the electron was somewhere inside. How much energy was required to bring it on to the surface of the metal? That is known as work function. The next one is threshold frequency. See, not for every threshold frequency. What is threshold? So threshold frequency. What is threshold frequency? Threshold frequency means, see, when the light is incident, doesn't mean that electron will come out for every frequency. For certain frequency, it will come out. Example, I am writing VIBGR. Okay, out of this VIBGR, which color has more frequency? Highest frequency. Huh? Highest frequency. Out of these 7 colors, which has more frequency?
So red. No, sorry, not red, violet.
Violet has more frequency and less wavelength. Red has less frequency, more wavelength. Understood? So that is why we use red color light for the danger signal. You can see red from a long distance also. Okay. So not for every radiation the electron will be emitted. Like I have taken some color because it is also available for infrared and UV radiation also. But it won't be, you can't understand infrared and ultra for what frequency. So I have taken some visible, for example. Maybe for red color light, when the red color light is incident on this metal, electron did not eject. The electron was not coming out. They tried for orange also. Electron did not come out. Maybe for yellow also they tried. Electron did not come out. Then for green it started coming out. So that particular frequency is known as threshold frequency. Okay. So the minimum frequency. So the minimum frequency of the incident radiation. The minimum frequency. The minimum frequency of incident radiation for which electron is ejected. Electron is ejected is known as threshold frequency. Is that clear? Please copy this. If you have any doubt, please ask me.